Welcome to Physics 2212, Lab 4, Circuits and Capacitors. The main goal of this investigation is to predict and examine the behavior of circuits in a simple circuit was modified. In multiple ways to examine the behavior of simple circuits in an RC circuit was constructed to examine the behavior of RC circuits. Importantly, circuits are constructed in the fast simulation circuit construction kit. The main findings of the investigation are shown, including the time constraint of an RC circuit, two key concepts of the node rule and the loop rule. The node rule states that at junction, the current entering the junction equals the sum of the currents from each fork of the junction. When the junction recombines, the node rule states that the current entering a junction equals the current leaving the junction. The loop rule states that the difference in potential for round-trip path around the circuit equals 0. Importantly, the loop rule can be used to calculate in the current and the potential difference at different areas of a circuit. Electrical resistance measures how an object slows down the current, and when constant can be defined by Ohm's law, which states that the resistance is equal to the potential difference divided by the current. When resistors are parallel, their equivalent resistance is the sum of the inverse of the resistances of the resistors. When resistors are in a series, the equivalent resistance is the sum of the resistances. Capacitance is the measure of charge that can be stored in the capacitor for each unit of the potential difference. Capacitance is equal to the magnitude of the charge in one capacitor divided by the potential difference, which is equivalent to the area in the vacuum permittivity divided by the separation distance. Here are some visual models for the circuits that were created in the investigation. This system is the device measuring the current or potential difference in the surroundings is the circuit being measured in one part of the system. Circuit was created with parameters shown. The ammeters are then measured, the current flowing through the current. Importantly, the predicted current and measured current are nearly identical when the ammeter is reversed. The measured current is negative as the current enters the ammeter through the other end. The next part is the same simple circuit is used by one ammeter is replaced with a voltmeter. The result is measured the potential difference of 3 volts from their batteries in the current of 0 amperes is due to the high internal resistance of the voltmeter, which essentially opens the circuit and impedes the flow of current. The next part, the voltmeter is replaced with a wire, and the potential difference at different points in the circuit were measured. Importantly, the potential differences satisfy the loop rule as the sum of the potential differences equals 0 volts. The graph in the shows the sum equaling 0 volts. The next part in the same circuit is reconstructed such as the ammeter is parallel to the 100 ohm resistor. The resulting current is greater than the current from the original circuit because the resulting junction allows for more current to bypass the resistor, allowing for overall current to increase. The next part, the resistant values for different components of the simple circuits were calculated using Ohm's law and experimentally determined the values for resistance. The resistances of these components were calculated. The next part, the RC circuit was constructed with components shown on the page. Then the time to charge the capacitor and the time to discharge the capacitor were measured. For each resistor, the time to discharge nearly equals the time to charge the capacitor. Between two capacitors, the 20 ohm resistor leads to the near doubling of the time to charge and discharge relative to the 10 ohm resistor. The next part, an RC circuit with the components shown on this page was constructed. The circuit was then closed to allow the capacitor to charge. Then the battery was removed and the circuit was closed again to allow the capacitor to discharge at 1 second intervals. Up to 20 seconds, the potential difference of the capacitor was measured. Finally, the plot of the natural log of the potential difference divided by the initial potential difference was taken over time, and the plot giving the linear slope, which is then used to calculate the time constant of RC circuit. The RC circuit's time constant equals 4.94 seconds. Note that in part 5, the calculated resistance values are greater than the actual resistance values due to the lack of precision. The lack of precision and other sources of error include rounding errors during calculation, timing errors, when determining when the current reaches 0, and no consideration of the resistance in the ammeters or wires.